Hi everyone, welcome to Vocal Academy. See this problem. So this is a problem on radius of curvature. So whenever the given curve in Cartesian coordinate system. So we'll observe carefully here. The given curve is a function of x and y, and variance is a constant. So it is a coordinate system, Cartesian coordinate system. Okay. So at a point a comma 0, we want radius of curvature to this curve. How can you find it? So first of all, radius of curvature is represented with a symbol rho. So whenever the given curve in Cartesian coordinate system, so what is the radius of curvature? That is rho equal to 1 plus dy by dx. So for this term whole square. So for completely whole power 3 by 2 upon second derivative. That is d square by dx square. So this is the standard formula for finding the radius of curvature whenever the given curve in Cartesian coordinate system. Now according to this formula, we need first derivative and second derivative for the given curve. So first of all, find first derivative and second derivative, then substitute in this equation, then finally get radius of curvature. So you are asking at a point, so substitute at a point also at a time while finding the derivatives. If the point is not given, no need to substitute, just simply substitute derivatives. But he is asking a point a comma 0. Now find the derivative of for the given function. So that is dy by dx. So first of all, find the derivative of given function y. So here y is x cube into x minus a given. So expand this, it becomes y equal to x power 4 minus ax cube. Now apply derivative for this. That is d by dx of, and y is x power 4 minus ax cube. That's equal to, so derivative of this term is, means it is in the form of exponent formula, that is 4 into x cube minus, it was also same, so minus a into 3x square. So it becomes 4x cube minus 3ax square. So this is the first derivative. But here we want radius of curvature at this point. So substitute this point at this equation, we will get, so here this is x value and this is y value. So wherever x is there, substitute x equal to a and y equal to 0. It becomes 4 into a cube minus 3a into x is a, so a square. It becomes 4a cube minus 3a cube, that's equal to a cube. So this is the first derivative. After substituting the point, it becomes a cube. So this is first derivative dy by dx. So after substituting a point, so whenever x comma y equal to a comma 0, this is the value, that is a cube. So here we want second derivative, means derivative of this function will get second derivative of y. So that is derivate this function, we will get second derivative. So d square y by dx square. So derivative of this is 4 into 3x square minus 3a into 2x, that's equal to 12x square minus 6ax. Here we want second derivative at this point. Now substitute this point in the equation, that is wherever x is there, substitute a and y is there 0. So it becomes 12 a square minus 6a into a, that's equal to 12 a square minus 6a square, that's equal to 6a square. Now substitute these two values in this equation because we want radius of curvature at this point. Initially only I substitute the points here, then we can easily simplify it. Now substitute the values here. So 1 plus dy by dx we got at the point a comma 0, that is a cube. So for this we have a square is there, apply square. For this overall we have 3 by 2 is there, power upon second derivative we got at this point, that is 6a square. Now carefully come here. So 1 plus a power m whole power n formula, that is a power mn, it becomes a power 6 whole power 3 by 2 upon 6 a square. This is the radius of curvature for the given problem, and this is the process of simplification. And thanks for watching. Please subscribe, like, share. Thanks.